Okay, I'm gonna skip the intro. Well, hello everyone and welcome. Hi there. Hi, Flame. I'm gonna just skip the intro, get right into it because, yeah, that's actually precisely not actually the hydrogen bonds, molecular orbital theory. When it goes to the electron video, I finally finished everything I had outside of YouTube, and because of that, there's only one last chapter left, which is the example chapter. So the chapter in which I would actually provide examples, two of them, for the molecular orbital theory, and that's precisely what we'll be animating today. Hold on, let me play some music. Hi there, Rashan. Skipped school for this. So please don't skip school for this. I do this every day. School is important. Okay, there we go. Hi the stick, and hi lamppost. All right. Let's get into it. So, actually, for this chapter, I have nothing. It's actually really convenient you joined in. Research on examples might be a little tough. No. It won't be too advanced of examples. No. I'm not going to go into the actual equations because that's kind of irrelevant to the... Like, every single person who actually needs the equations for the molecular orbital theory already knows about the molecular orbital theory. You know, this video won't really be for people who are already good when it comes to chemistry. This video is to get people going into chemistry. You know, so that they'll realize there's another way. You don't have to actually memorize all the different exceptions and stuff. There is the single theory. So yeah. The sources show much about around the molecules of few alkenes. Oh no. I already know the two examples I want. I already know the two. I know I should probably include the third one. Also, actually, Flame, that any recommendations you would have? Hold on, I need to open up the. Is this one? No, it's not this one. Is it? No, that's MSDS. I was checking to not poison myself. Is it this one? No, that's a 35-page long document just about movement. Is it this one? Yes, it's this one. Okay, cool. So, the two I showed, well, the first one will be water. That's why it's in the title, because the first one will be water, but the second one is this, yeah. That's actually why I needed it. But a couple of days was it the week? I don't know, time is melting. Back when I asked for it, that's actually why I needed it. I needed it for this video, but only now have I gotten around to actually finishing it. Geesh, my stuff may be short, but what's popping? It's a video popping, actually. Once I finish this chapter, yeah, a whole separate document just for the chapter. Good enough. I'm gonna end the live stream, then I'm gonna work on the video for 40 more minutes and then upload it. Okay. Makey, good morning. Me just woke up and saw the notification for your stream. Yeah, for me it's similar. I woke up, but I finished all my work yesterday, which means that I could go right to streaming. Isn't that festive? Why does water exist? That's a good question, isn't it? Anyone care to share? Ah, who am I grilling? No one, hopefully, because I'm pretty certain that's a crime. Water exists because of bonding. I love how you're just casually using my third year lectures as an exam topic as inspiration for this. Okay, well, technically yes, but it only technically, because in practice, I'm not really going. Well, it seems like, you know, it seems impressive that I would use third year lectures for my videos until you realize that the only reason for why this video is even possible is because, you know, you basically taught me all of this. It's like, I'm not really using third year lectures, I'm just using information I got from you. And this is just the graphical representation of what I'll do in 3D today. This lecture will be something special. I mean, oh yeah, it has. I do give off the weird physics teacher vibes, don't I? Is the only info you have? Yeah, yeah. I don't want to research chemistry. That's why would I research chemistry when I can just waste your time? I'm a good person. And yeah, why does water exist? Okay, so for water it will be easier because band diagram water, those exist. Those are all everywhere. That's everywhere over the internet. Nope, that's not. Wait, band diagram or am I an idiot? Am I an idiot or am I an idiot? Orbital diagram. So one of them. Average lecture is special. I'm special. There we go. That's what I'm looking for. Water! Isn't this festive? So, oh wait, but for water, hold on. Oxygen to P. So, oh my god, like hide the heads, like. Good image search molecule followed by molecular orbital simulation is usually at least one result that show properly. Really? I do kind of want to do benzene, kind of, but I feel like it might confuse everyone. That's not benzene. Oh no, I shouldn't do benzene. I shouldn't do benzene. I should very much not do benzene. I could do... Benzene will have 100%... For example... I feel like... I have one good idea. Pretty good idea. I could do methane and then use it as a fit, because here's the thing, water will be the, that's that water, that's water. Water will be the kind of hook to show people that, yeah, you can actually use this, is actually pretty cool, it explains bonding really well, that's why it exists. Then I wanna do this because this is really fucking awesome. It's probably my favorite, and yes, the swear is important in that sentence because this is by far my favorite example of like using chemistry in a practical way, because this basically gives you like a, this is a medical answer, well no, this is a chemical answer to a medical question, which I think is awesome. Mickey, what are we gonna do today? Well, can I actually show you the video? You know what, let me show you the video. Well, not the whole video, I'm gonna only show you the timeline in Premiere. For the video, here's the thing. Give me a second, Premiere's opening, I don't wanna spoil any other videos I'm also making on the side. My neighbors are throwing something, that's not great. Alright, there we go. This right here. This is the video. So far it's 20 minutes long. It ended up being a bit longer than I was expecting. Why do water bonds? No, why do waters bond? Why do them waters bond? Why isn't water explosive short? Why isn't water explosive? Yeah, that's, I mean, it's the same source. Simulation part for some, they got too in depth, something completely random. I mean, here's the thing. This is the video. The video I've been foreshadowing such a long time. I finally got around to it with the initial quick introduction, with the which is the confusing chapter, which is which is the introduction to electron, with this, which is introduction to orbitals, and with this, which is the non-quantum introduction to orbitals. And what I want to do today is I want to finish this chapter, because there is a whole chapter missing at the very end. And that chapter is the application chapter, something like that. That's what I want to do. And so the first example, water. showing how why does water bond, why isn't water explosive. Oh, actually, you know what, lamppost, that is it. I should probably just go for why isn't water explosive. Oh, because that is a way more interesting question, isn't it? Why isn't water explosive? I'm just gonna copy paste. That video looks amazing. I haven't even shown you. It's just random thing I threw in. Hold on, let me. What was I trying to do? I don't know. The Google search simulation seems to prompt more advanced results. I see. Okay, but I can't use Google though. Well, I mean, technically I can. Just gonna have to solve CAPTCHA for 3 minutes for every search result. Explosive hydrogen, mix it with oxidizing oxygen, and you get that's literally the shot. That isn't it? That's literally the text from the shot. Water. Why? We think our whole existence to find this answer. Yeah, it really is one of those. The ghost make it look so bizarre. Oh. I never liked this make it all that much. No. Oh, I didn't even do a poll on which was the best make it. Oops, oh, forgot about that. I need to get my crap together. Well, in order to answer question, we'll first have to ask the question of why is hydrogen explosive? And the answer is it isn't. What's really funny is that at this point we've actually been walking a fair bit in another video on stream, as you're probably aware. And what's really funny, this video also explains it, actually. It's chemical energy. Chemical energy isn't the atom itself. Actually, the protons are the neutrons and protons are surprisingly irrelevant. We think of electrons only as electricity, but most matter, most meaningful properties of matter, they're just electrons. Isn't that wild? Like what you're seeing, when you look at something, what you're actually seeing is electrons. This is kind of, it's bizarre. Nah, no, maybe I'm just weird. Why is hydrogen explosive? Good question. Well, it isn't. Simple answer. Ghost Makey is cute. I don't know, it's just a mask. My name has come. I don't plan on seeing the sunrise, so see all of you later. Bye, Ninja. Wait, what do you mean? Oh, it's because it's late at night. Okay, bye, Ninja. I got worried for a second. Okay. I'm throwing linear algebra. What do you mean? I'm not sure real quick, but I'll have some time to join VC for a bit before walk. Well then, VC is always open. My Discord is breaking a bit. Oh well. There we go. I'm pretty sure to stupid. Oh, no. No, you are not. No, you are not. Don't even say that. No, you are not too stupid. It's linear What makes you think that, Unisoc? There's always something. There's always this one topic. I don't know, I need to close my window. The neighbors are a bit loud. And I'm back. self-oriented bonds. Hydrogen isn't explosive. Hydrogen. Gas is. Why is that? And now we'll have to go for the orbital diagram. Now, for this orbital diagram, obviously this is like, what should I call it? It's a very childish kind of. My approach to the diagram will be very childish. The reason why is that there is no numbers, okay? This is all just relative graphics going in all directions, which means that hydrogen bond will be right here, oxygen will be lower, and that's all we know. All we know is that hydrogen will be higher, oxygen will be lower. Wait, why are there two of them? Oh, two hydrogens, makes sense, okay. Oh yeah, because it's a single for... It's a single bond for 3. Actually explaining how they mix might be... Oh, that's amazing! Oh, that's so lovely. Huh. And he will even have the energy. Well, isn't that festive? Oh yeah, that's really cool. That's really cool. water.lsbu.ac.uk/water/h2o_orbitals.html. That's really cool. I just don't understand the difference between these two at the bottom. That's the only thing I'm missing. I don't really get what's different about them. Because this is phase, correct? Oh wait, that's... no, what? Hold on, that's from hydrogens. Okay, that's the S of... oh my goodness, okay. This is 1S from oxygen. It's not bonding, I'm an idiot. It's not bonding, okay. Alright, cool. It's the 1S from oxygen, which is not bonding. 2S from oxygen is actually bonding, and obviously the lowest energy possible is the all-in phase. That's obvious. Then the 2S is this one. 2S lowest energy is all in phase, and then we have out of phase. These all have different energy level. I won't sit here and pretend like I know why exactly. My question exam was, what is the smallest unit of matter if considering quantum theory? I wrote the smallest the energy clamp can get at a region of space. I'm proud to say I got negative marks. What? Energy clamp can get at a region of space. Smallest unit. Wouldn't that be something like Planck's energy? Wouldn't that be one of... Is there Planck's energy? Is that Planck's energy? Planck's unit, yeah, it's what I'm looking for. I think. Why am I going down the rabbit hole? Make it stay on point, stay focused. when we set it on fire. Fire with oxygen. Why it explodes? Why is that? Why is it that it explodes when we set on fire with oxygen nearby? The energy is literally distributed equally in the region, so I guess they are indeed negligible mass and negligible energy. You know, have energy. I won't sit here and pretend like I know. Actually, it's very convenient if flame conjunction with flame. That's why these have different energy. First of all, ptable.com, very important. Oxygen, there we go. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Start with high. Using our players. Actually, I might need to include the numbers, you know? Gas, bonding orbital diagram. With energies, if I may. That's fluorine. Yeah, these are simple ones, but relation. Bonding. Wait, what did the flame say it was? Molecular orbital simulation. There's not a couple of physics. Oh my goodness, that's loud! Yeah, you can hear it. I'm sorry. My neighbors are just out of their mind today. Talk about physics to make it chemistry. I don't mind. I don't mind. I ain't understanding much anyway. No, what I'm looking for is this, but with specific energies. Energy, but give me the numbers. Give them numbers. That's a chemistry. Makey, do we have a physics channel in T? No, not yet. We have a math and chemistry channel. Hi, Dharmic. Hi there. Oh boy, hydrogen gas molecular orbital simulation energy values. In electron volts. I mean, this is energy, right? I'm not looking up energy volts. That's charge times voltage. Energy. There's one answer I have. I shouldn't go with pictures actually. Why am I such an idiot? There we go, molecular orbital theory. My beloved chemistry library text. Yes! For hydrogens. But like, what's the... Okay, there's simple stuff. Simple stuff. Very simple stuff. Simple stuff. Oh! Yes! Yes! Oh, hell yeah. I'm really sorry about noise in the background, there's not much I can do. Make economic squarety physics. What would squarety physics even mean? Okay, so we have wait, why is the bond energy of this lower than this? Also kilojoules per mole. Just do electron volts. Don't the moles, please. Beg you. Also, hold on. Is any bond energy what we're looking for? Mm-hmm. The number of bond electron molecule of order. Mass bond order. Lowest energy molecule for in this case, the bond order is this, because the bond order is greater than 0. So... calculating bond particular stability. Bond order of Hamilton. Y'all have fun in chat, honestly. Wait, the higher the energy, the more stable, correct? Or am I an idiot? A flame!
Oh.
Wow, what a perfect timing you have. Hold on.
What's your question?
Yes, so I'm just reading up on Nabotex right now, and I don't know if you can see on stream.
Yes.
Right here I have this table, and
Yep.
in this case, would the higher energy mean more stable or less stable? As in, actually, no, the better question. Bond energy. What's bond energy exactly?
I'm just checking my understanding is right. Yeah, okay. I think more energy is more stable.
Yeah, that would make sense because otherwise
it's the amount of
helium would
energy
be...
you need to break the bond.
Oh, so in this case, wait, paint. Hold on, my taskbar is broken again. Okay, so like for hydrogens, the amount of energy would be, this would be the bond energy, right? The energy needed to move the
That gap.
electrons up from the sigma.
I think so. It gets more complicated when you have the antibonding orbitals involved, because you then have stuff like bond order. But well, like it shows here, like if you had H2+, it's like you have one electron in the higher one and two in the lower. So I don't think it's as simple as just adding up the differences. But yeah, I think what you're saying is correct. Like if you just have two electrons. Although what you need to consider as well is that there's an energy of pairing up electrons uh compared to having them in separate orbitals and things. So yeah, I don't think it's quite as simple as just that gap.
That's from I'm looking for. Basically, I found this, which is amazing. This is just outstanding, in my opinion.
Yes,
Yeah,
orbital for water.
yeah. This basically solves my entire problem for water. I'm just trying to find this, but for oxygen and hydrogen gas.
Okay, let me see if I can find it.
10 a.m. on a Thursday. Who has the time to freaking this much noise?
I see what happens when you Google it. It just talks about the like the energies of the orbitals because it's doing a diagram. Hmm. I think I have found. Let me send you this. It's a bit annoying because they haven't ordered the orbitals in like lowest to highest energy.
Oh,
This
it's
is
just a
this
list,
is
but
like a few of them.
that's still
Huh?
pretty useful.
Yeah.
Really useful. Okay, so this is non-bonding ion. This is the wait anti-binding and anti-bonding. Oh no,
I think that's a typo.
is that a type? Okay.
Where does it say binding? Yeah, that's a typo.
Oh, there's a 3D model for all of them. And the energy. How festive. Can I load all? Oh, sick.
Oh, it's showing the vibrations.
Oh, I'm not on that level.
Oh, vibrations are great. It's all IR spectroscopy. Um, Yesterday my supervisor was like he had this vibrational simulation up for some really big ligand, and the whole molecule, it was like this big organic molecule. The whole thing was like vibrating with different bonds stretching and wiggling and stuff. It was really cool. And then I asked him about it, and we talked for like an hour about computational chemistry.
I gotta say, there is something about watching the video of you sent on the chemistry channel, of like
With the fluorescence.
yeah, I mean, yeah, the spinning one.
Yeah.
There's just something about watching like uh, experts in like a professional lab doing actual chemistry, just absolutely shit posting about it.
Yeah, it was like the end of the day, and we turned off all the lights in the lab just to see like the fluorescence clearer, and we just started screwing around. He was the guy flashing the light is my supervisor, and he was like, "Oh, it's like the rude sandstorm when you flash." Oh, he's great. No,
Oh,
it's
that's
really
great.
good because like everyone there is like excited by the same stuff I am, you know, and that's really nice.
That is really amazing. I'm really happy for you. Great.
Yeah, it's going really well. Right now, I've got a reaction going. It's the one with the really toxic stuff, the propygyl bromide. So hopefully it hasn't spilled because
You just say
that'll be
hopefully it
good.
hasn't spilled.
Yeah. Well, because I left it overnight. We had to because some reactions take a while, so you just leave them
Yeah,
in
but
the
like,
lab.
did you just say? Oh yeah, this is the one with the extremely toxic stuff. Hopefully it hasn't spilled.
Well,
You
yeah,
know.
because if it has, then I'll walk in the lab and start crying because it's a lacrimate.
Well, I guess that's true, but like, still, that's your problem.
Yep.
This extremely toxic stuff could spill over everything. In the end, now basically start crying. Not even because I'll be sad. No, no, no. It's basically just so toxic.
Yeah.
Just casual. Just okay. You know what? Yeah, I think this is it for the oxygen. Why can I not find a single one for hydrogen though? That's just a bit weird in my opinion. Hydrogen bond energies in a simulation. It feels like hydrogen would be the simplest one, wouldn't it?
There you go. I found one.
Okay, well then I'm. Cool. Oh no, 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 that's not what I'm looking for.
Oh,
I'm
what
looking
are you
for
looking
this
for?
one, except with the energies. You know this.
Wait, which one? Oh, this.
Yeah,
Oh,
because I want to make it actually
all the exact energies. Might be difficult to find a thing that lists all of them. As in, like, shows the energies, shows the diagram, and also shows the simulation.
yeah. Well, diagram and the energies. Diagram and the energy is the most important because when it comes to the simulation, that's I can figure it out. Oh wait, is it 436? But what is the unit? Oh yeah, festive. Okay, so when I got them, except cool. AU energy unit. So now I got the thing I needed for water, for hydrogen gas, and for oxygen gas. The problem is, all of them are different units because of course they are. We have water in electron volts. We have bond energy right here in kilojoules per mole because of course. And in this case, is an atomic unit of, and there is atomic units. Oh, atomic unit of energy.
Oh, I found one on vanadium benzene.
Well,
It just popped up. In the Google results, it just popped up with some paper on
that's a sign.
vanadium bonded to benzene.
That's a sign.
Yeah.
Oh,
I mean, while I was talking to this guy about computational chemistry, he was saying we can just do some for my project. So I could make one of these diagrams for my compound by simulating it. Which, but it's like a massive molecule because the ligand is like you got the ligand part and then a spacer and then the fluorescence part, and then it's bonded to a vanadium as well.
how long would that sort of simulation take actually?
Sorry?
How long would that sort of simulation take? Or is it like
Oh, I've actually got no idea. It depends on the program you're using and how many. There are like different there are different ways to simulate it, and the more accurate ones take longer.
also is
So
it just
it's
like
like yeah.
you just make a molecule and you let it simulate, or do you need to like
I'm not sure. I don't know how it works for that. Because we were talking more about vibrational simulations, but I would want to look at
I mean in this case
the
might as
the
well.
molecular orbital one would be useful because it's fluorescent.
I feel like it would be really cool if you did that.
Yeah,
Go for it. Don't let the haters get to you. Oh,
no,
so
we'll see. Like he knows I'm interested in it, so if we have time, he'll probably just let me do whatever. It's a lot to learn though. Like we haven't done any actual computational chemistry in our course, which I think is really weird. But I guess it's just difficult to get into.
Atomic unit of energy. What? E squared divided by A. What's AH? Give me the conversion.
What units are you converting?
Kilojoules per mole to electron volts, and both of them into atomic energy units.
Okay.
Yeah,
Atomic energy.
apparently.
I don't even know this. I don't even know this unit.
Yeah, that's the first time I'm seeing it actually. I mean, I'm assuming it's AU. That it's got to be atomic
That's astronomical unit.
astronomical unit.
Yeah,
Is that the real thing? Right?
that is another thing that just popped up on Google. Yeah.
Oh no, but that's length.
Yeah.
Okay, that's. I think that's.
Okay. No. Yeah. Yeah. No. I have found AU for chemistry. Yeah.
Yeah, it's because it's atomic units, which because you know.
In the Wikipedia result, it says it says not to be confused with atomic astronomical units because one has the dots and the other one doesn't. Oh, that's funny.
I love how they just decided that we don't have enough units for energy, so you know we should get some more.
Yep.
Converter. Energy converter, yes. Oh, festive. Okay. Wait, why is this? Oh, because it's kilojoules per mole. Of course, it's a kilojoules per mole. You just had to add this. You just added this extra step just to. Nah. This is an electron volt. Just one electron volt. Okay, that's what's accurate. Boy, I'm glad I actually want this video to be useful, and because of that, I'm going through this process, even though no one will care. Huh. Cool.
I feel like all you need to do is just show some pictures of molecules, just so people like understand how it applies to bigger molecules.
Yeah, but well, for this last one, what I want to do is I want to go through two examples. First one is answering the question of like why isn't water explosive by answering the question of why is hydrogen explosive by being like, oh yeah, the reason why hydrogen's explosive is because when you burn hydrogen with oxygen, then both of their bonds actually have more energy than the water energy. So you can see, I want to show basically, you know, the electron energy is dropping and then being emitted. So like water isn't explosive because hydrogen is explosive, only hydrogen is explosive because its bond has more energy than an alternative. And for that, I could do it with just, I would need your blessing though for it to, because.
I mean, for a couple things with that. For one, I think hydrogen technically isn't explosive, it's just flammable.
Close enough. It's like,
I mean, yeah, close enough. I think for something to be explosive, it has to one be very reactive, and two, it has to produce something with a higher volume than what you started with. And so that's why like lots of nitrogen containing stuff is explosive because it makes nitrogen gas and that's high volume. But when you burn hydrogen, it just makes water, which then it takes up the same volume. That's one thing, and then also what you described about the energy dropping when you do the reaction, right? Like you start with higher energy, you go to lower one. That's just all exothermic reactions.
yes.
Like
Yeah, but you know that's actually precisely when I want to go with this example, because you know
Okay.
It's the simplest example I can think of for all exothermic reactions. And basically, so yeah, that's precisely what I go. But I would need your blessing to do it without the actual energy numbers, because I feel like
Yeah, I mean that's fine. No one really cares about the energy numbers
I
anyway
know,
when
but
they're
it
watching
feels like
video.
the doing it without the energy numbers is kind of uh, too easy. I know.
I mean, I think you should refer to the energy numbers to make sure you're doing the right thing. But in terms of the video, no one's gonna care
Yeah, in that case, I could just use
really.
this because then the height is gonna match. We have the heights for hydrogen, heights for oxygen.
Yeah. Yeah, exactly. Like the heights on this are just yeah.
All right, go for it then. Oh, and the other example, for the other example, I won't complicate it too much. I'll basically, that's actually how I'll end this video by being like, hold on, that's the PowerPoint. By being like, yeah, so this is why uh, carbon, oh my goodness, carbon oxide, carbon monoxide. Carbon monoxide. Jeez, brain freeze. Every single time I try to think of the CO name, and my brain always goes for carbon dioxide for some reason. Okay, carbon monoxide. Why couldn't you just call it carbon? It doesn't matter. Carbon monoxide. So for carbon monoxide, the way I want to finish off being like, okay, that all makes sense, but in science, it has to not only make sense, you have to make sure that it's accurate, and that's the whole point of chemistry. Is actually doing the actual legwork to check if your hypothesis makes sense, because and then being like, for even larger molecules, you need to actually test out more. I don't know. I'll think of something. This is cool. I just really like this.
Yeah.
So awesome. I'm just hoping the video won't be disappointing, honestly. It's very
I'm just
intimidating.
reading actually, and actually a lot of explosives are endothermic. So they actually
Really?
when you do the reaction, it actually absorbs energy. But what makes it explosive is just like
Actually
entropy,
makes
like the
sense.
gas production.
It actually makes sense, kind of. Because wait, is endothermic absorbing energy or absorbing
Yes.
thermal energy?
Uh, uh, I think just thermal energy. I
Yeah,
mean,
because
what other
then
energy would you absorb?
that would make sense, because then it's explosive because it's absorbing thermal energy and turning it into, well, the explosion.
Uh, the the way to think of explosives is they're just producing a lot of gas. Like
Yeah, so
they're
basically,
not really putting energy into the force. They're just making gas.
yeah, so the endothermic explosion would basically mean that it's taking in the thermal energy and turning into chemical to make larger molecules, to make more gas to explode. Right?
I guess so. Yeah.
That's actually
And it
also
doesn't
really
have to, it
cool.
doesn't have to be larger molecules, by the way. There's a kind of general law of gases, which is that usually 1 mole of any gas will take up the same kind of volume. So it's more about the number of moles of gases that you have rather than the size of the molecule.
Ah, yeah, misspoke. You know how intimidating like earlier on you mentioned how I'm just using the third year PDF you sent me, right? But you know how intimidating it is, because I am nowhere near nowhere near the third year level, nowhere near
Yeah.
it. You know how awful it feels to like make a full blown video about the topic in which you're not an expert in. It's awful. I hate this feeling.
I mean,
Why do I do
I think
this?
it's cool to just show it off, you know?
Yeah,
Like,
it's kind of what I'm
yeah.
going for, but still, still bloody awful. It feels like I'm about to have an exam where my professor is like a Nobel Prize winner and I didn't even study. It's kind of what it feels like.
I mean, it's kind of a general issue with science is that you have to build up all this understanding to get further. And so if you try and look too far, you have no idea what's going on, and like you feel like you're missing out a lot.
Yeah. And then once you build up basic understanding, you just switch from quantum mechanics to chemistry because there's actually okay. You know what? Never mind. I just realized I'm talking to you. Doesn't matter. I was about to say like, oh yeah, because I built up this basic understanding of quantum mechanics, and I switched to chemistry, and then I realized I'm just talking with you, and you like did that successfully. It does okay. So it's
Well,
only
I
a me
mean,
problem. Okay.
my quantum
Yes.
mechanics isn't great. Like, I kind of hated all
There's
the maths we had to do, and I preferred the concepts and not the maths. So
Yeah,
I
I can
preferred like applying the
sympathize.
concepts.
The maths was awful. Well, not
Yeah.
all. Okay,
I mean, it's
not
good
always.
because like nowadays, like all the maths is kind of done anyway. Like they've done the maths, and they now have programs that will just simulate these approximations, and so you just put your stuff in
Yeah, but
and check that the simulation is doing what you want it to, and it will just do it.
that's actually the curious problem because in quantum mechanics, the vast majority of math you have to do is differential equations, and like
Yeah.
we still don't have algorithms for those. We have some
Yeah.
programs like there's the new AI like experiments, so AIs that can actually do math
Mm.
and not just solve equations only. I mean, not just compute equations only, actually do math. But still, the differential and differential equations suck. I haven't seen a single
Yeah.
person that actually likes partial differential
Yeah.
equations.
No, it's not great.
And everything in quantum mechanics is partial differential equations. In relation to position, time, separate, partial. Yay! And no one's happy.
I do need to go in a few minutes.
It's fine. I
to
understand.
work.
I'm so thankful you actually joined in. You helped me a lot.
Yeah, I'll be around anyway. Well, in the evening, so you can send me like stuff from the video, or to be honest, you could just have me watch the video and then pick up bits. But, it's up to you.
All right. Well, thanks, Flame. I won't
Yeah,
take up
no
any more of your
worries.
time. Bye.
Let me know if you have any questions. You can just DM me a random question, and I can probably answer like during the day. So yeah.
Okay.
Okay.
Thank you.
All right.
Bye.
See you. Good luck. Bye bye.
Ah, it feels nice to have Flame around, you know? Whoa. Can you imagine that without Flame, I would actually have to research all this myself. Myself? Make it? You drunk? Maybe. I am dizzy. I'm poisoning myself, aren't I? Okay. So, Virgin gas is simple. Now we have we have the ones orbitals, both of them with only one electron. Now, when they bond, they merge into not quite merge, but it doesn't matter. The point is, they merge into the sigma orbitals. This time with different energies and occupy the lower energy one. We've already been over this before. Yes, in the video I've been over this some other. The point is, for these. And now what we need is the orbital diagram oxygen gas. This is what we need. This precisely. Which is the molecular orbital diagram for oxygen gas. Can believe it, which I'm also gonna save. That's my memes. Known to my memes, only into my video folder, which is going right here. There we go. Save. Cool. Now that we got that, except more complex. Let me see those memes. I already sent them to Discord. You can just go on Discord. Except more complex. We have more. Join end date. Get much. Oh boy. The keyboard smashing sound is making me smash my own keyboard. It's quite odd. Most people like it. Even I don't like it. Been going on for an hour already. Hold on. So I have this animation, which I have to. There we go. This is done. 540 to 580. Another animation to do. 48, 49. There. That much. It's complex, but the point is what was the 500 special? A really long live stream. A really long live stream. That's gonna be the 500 special. A really, really long one. It's gonna be the longest one I've ever done. That's the hope. And that's what's gonna happen because I'm determined. I feel like I'm gonna end the stream now. It'll be quicker for me to work on this off stream because then I can also work on the because then I can record all of this and work on the animations right away and work on the segue from the previous chapter to this chapter. But 72-hour stream, no, I wouldn't survive that. 72-hour stream, absolutely not. We'll see how long we can go. Anyhow, for now, I suppose that'll be it. Thank you everyone so much for watching and have a great day. Bye.